Welcome back in this video tutorial of C programming. In this lecture, we're going to discuss about how to work with 2D array, that is a matrix or tabular form data in C programming, which is comprises of rows and columns. So let us see the definition first. What is 2D array? A 2D array is essentially an array of arrays. Okay, array of arrays, important point, array of arrays, and is often used to represent data in a tabular or grid format. Mostly we can say in a matrix form, simple, comprises rows and columns. Okay, what is the meaning of this particular term, array of arrays here? Let me draw a matrix. So here I have taken a 3 by 3 matrix. What do you mean by array of arrays? Now, in 2D array in C programming, here each row can be represent a 1D array. Each row can be represented as a 1D array. So this is 1D array, this is another 1D array, and this particular row is another 1D array. And it is a collection of 3 1D arrays, so that's why it is called an array of arrays. And each 1D array have a fixed size, that is number of columns. Okay, so it's often used to represent data in tabular or grid format. So here you can see it is represented in the tabular and grid format. So let us first see how we can declare a 2D array in C programming. This is the syntax. So it is started with a data type, as we have also followed the similar kind of syntax for 1D array declaration. It starts with data type followed by the name of the array, or you can say the matrix, whatever, and it will be have 2 dimension instead of 1 dimension. That's why it is called 2D array. First dimension will be known as number of rows, and the second dimension will be represent the number of columns. Okay, so the data type can be any valid data type that we have already seen, integer, float, character, double, any valid data type, and the rows and the column size should be a value, an integer constant, and the value should be greater than equal to 0. Sorry, greater than 0. That number of rows and columns should be greater than 0, not greater than equal to. Okay, it should be greater than 0. A positive, you can say a positive integer, just like 1D array. So what is the main difference here as compared with the 1D array? 1D array will have only one dimensional data in the form of row, right? But in 2D array, we will have multiple 1D arrays and a fixed number of column for each rows, fixed number of columns, or you can say equal number of columns. And in the syntax, it will start with the data type. We can take any native data type that is comes with the C compiler, and the name of the matrix, and followed by, in a square bracket, first dimension represents the row numbers and the second dimension represents the column numbers. So let us first declare one 2D array of dimension 3 by 3 into GDB compiler. Okay, so how to do that? So we can have a matrix, right? Okay, we have 3 rows and 3 columns. Done. This is a declaration of a 2D array of size 3 by 3. Right? Okay, let's move here. So now let's next see how we can initialize a 2D array. There are 4 different ways we can do the initialization for 2D array. Let us see the first one, that is row wise. Means we need to initialize row after row. Okay, one row after another row. So how to do that? What is the syntax for this? So I'm writing it here. You can see we need to initialize row after row. So in our case, the dimension is 3 by 3, right? So here I'll start with open curly brackets, and then we need to come up with like 1D array closed a pair of curly brackets, and how many columns? 3 columns. So you need to pass 3 values, and each row must be separated by a comma. So we moving to the second row now here, and now we have the last row. And once we finish all the rows one by one, we need to close the curly bracket that is represents a 2D matrix and must be end with a semicolon. So this is called row wise initialization. So this is initializing one first row, this is the second row, and this one will represent the third row. Okay, so let's do the same thing in GDB compiler. So let us initialize. At the same time, we started with the curly brackets, initialize row after row. We have 3 rows here. Done. Each row have how many columns? 3 columns. Okay, first row done. Second row done. And now third row done. Okay, even though if you want, you can break them into multiple lines, so it will become more readable. Okay, so and you can just level up this last line. So this is our 2D array in the matrix form of dimension 3 by 3, where I have done the row wise initialization, right? Okay, second one, we have a single line initialization. Okay, so how we can do this single line initialization? Just like 1D array, like this. Okay, here we should pass comma separated values, right? So our dimension is 3 by 3, so we need to pass total 9 elements. We need to pass total 9 elements. So here number of elements must be equal to row numbers multiplied by column numbers. Okay, so let's have another matrix here. Let me just copy this one. Okay, so we'll have another matrix mat2, and it will be single line initialization. So we now need to eliminate the row wise curly brackets. Now see, I have removed all row wise curly brackets. Let's compile this. Here we can see there is no error, although there is no output. I did not print anything, but our syntax are correct. Okay, so this one, first one is what? First one is row wise initialization. Sorry, initialization. And the second one is single line initialization. Okay, third approach, partial initialization. Like 1D array, we can also do the initialization for the 2D array partially. Okay, so in this case, when we use row wise initialization, we can initialize the row partially. Yes, done. So this is our partial initialization. Our dimension is 3 by 3, but here I have just passed 2 values in the first row. Second row have 1 values and third row have 3 values. Okay, so let us see this, how we can do that one. So let me just copy this first matrix. Okay, so I need to pass less values. So 1 values I have passed here, 2 values and 3 values. Okay, now let me change the matrix name, because I cannot have 2 matrices with same name. Okay, now see, there is no error. Okay, so this is called partial initialization. So now what will happen to the remaining elements that I did not initialized? Okay, so similar rule applicable for 1D array. If I partially initialize the matrix, non-initialized memory block will have the value 0. Okay. Fourth one is dynamic. So dynamic, two way we can do this dynamic. One way through input as a scanf. Okay, and another one we can do just initialize it in through loop. Okay, initialize through loop. So let's follow scanf, because scanf also need a loop, so we will easily understand the initialization through loop. Okay, so before we go into that scanf part, dynamic initialization, now we need to understand the memory alignment of the 2D array, so that we can work with the scanf for inputs. Look at here, this picture. Here I have taken a same example of 3 by 3 matrix. So here, how many rows? 3 rows and 3 columns. So if you remember, during 1D array, we have taken one for loop. Okay. So what normally we have written in that time? So we start with the for loop. Okay, we'll start with the starting index. It will go up to the size of the array, not including. Okay, so this was the for loop we normally write to take input for 1D array. So from the definition, what we come to know, it is an array of arrays. So here we need to count how many 1D arrays I have. So there are 3 1D arrays, right? So this is my row 1, this is my row 2, and this is my row 3. So we need a for loop which will represent the rows, right? In my case, number of rows are 3, and each row will have how many columns? 3 columns. So this is my column 1, this is my column 2, and this is my column 3. Okay, so now each row will have 3 columns. So you're going to use a nesting of for loop. Okay, so now here we can use the scanf. Okay, so here this one iteration, please remember this, one complete iteration of outer loop represents one array, one row, represents one row. Okay, so this one here, this outer loop will be represented by the row, and this inner loop will represent the columns. Okay, so here previously for 1D array we have write this way, right? Num of I, only one index. Now we need to pass 2 index. Okay, so in this case for mat we need to pass I as well as we need to pass j. So I will be the index of row and j will be the index of column, right? So let me show you in the GDB compiler. Now suppose I want to take input for which one? So let me just come up with another matrix 4. Matrix 4. What will be the dimension? We have dimension 3 by 3. So I've done the declaration here. So now let us take input. So here we can do we can take a for loop for integer I equal to 0, right? I less than, here we can easily understood the number of rows here. Okay, so rows equal to 3, and we also columns equal to 3. We can have variable dimension in rows and column. It is not necessary that it always come with same number of rows and column. It can be 2 by 3, it can be 3 by 2, any dimension, any valid integer number. Okay, so now here I am using rows, right, and this one. Now next we need to represent the columns. Done. And thereafter we need to just keep a message to enter the number. Enter number at index. So we'll have two index now, right? So we can print here %d and %d, how to get the index ij, and we need to use a scanf for taking input %d, and to pass the address of each of the location. Okay, so here you can see ampersand operator in front of mat4 that I have written inside the scanf. Okay, so don't forget to pass the address of operator. So it will give me the index, and then we can it will ask for the input. So once we get this input, we need to print it. So this is just for input, for taking input. So this is a dynamic way you can initialize a matrix or 2D array. And now we're just going to print the data. Print data. So here, sorry, let me just paste the for loop. Okay, so we'll also print in the matrix form, right? So here we do not need the scanf. Instead of scanf, we're going to print the data. So here we do not need this message. We simply print in the matrix form. Okay, done. After printing the first row, we need to move to the next row. So here a \n is necessary. Okay, so you can just have a printf here. The given 2D array is as follows. Done. Okay, let's run this. So waiting for the number. So 1 2 3. Here you can see initially it continue with the 0 0 0. So here come here. So 0 0 0 1 0 0 0 1 0 2 represents first index, represents 0, 0th row. Okay, and row will fix and column will increment it. So I did the same thing here. Okay, so one iteration, complete iteration of the outer loop is over here. One complete iteration of outer loop is over, right? So now we move to the second row, the second iteration of the outer loop. So that's how you can see the I is modified to 0 to 1, update to 0 to 1 due to this plus, and this 0 once the condition has terminate j less than columns. So our column is also 3. We have initialized it here, right? So it will be also now started from the initialization value j equal to 0. Okay, so now 4 5 6. Now see again my row has been changed. So 2 row already populated. Now the third row 7 8 and 9. Okay, so here you can see the matrix that we have taken from the user input, the values as per the given location, it is also printed. Okay, so while you do this, do the visualization for the matrix. And this line number 43, if I just omitted, let me show you what will be the issue in if I just omit line number 43. If I just, this one is comment, and let me just put this again, take input and see. Okay, now our input is over. Now you can see it, all the lines going to print into same line. So we're unable to identify the different rows. So that's why I have added this backslash n after the inner for loop. So complete iteration, let me just write a comment for you. Complete iteration means all columns of ith row is accessed. Okay, I hope you understand now how to access just by passing both the index, right? And the condition need to be satisfied. Index should be greater than 0, and if you're passing the row, it should be less than row and greater than equal to 0, and if it is column, it should be less than columns and greater than equal to 0, right? Okay, done. Okay, so here I have explained the two things, how what is 2D array. It is a kind of data structure, you can say linear data structure. It is an array of array and represents the data in tabular or grid format, right? And at the same time, we have seen the syntax, so we can take a valid data type, right? A valid data type. So we have already seen the data type integer, float, or character. Okay, any specific type you can take, and then you need to pass the number of rows and number of columns. It should be a positive integer. Okay, and the index always started from 0. Keep this thing in mind. And many way we can initialize in 1D array. We can do the row wise initialization. This is the syntax of row wise initialization. Then we can do the single line initialization. So this one is the single line initialization, and we can have partial initialization like C program, like 1D array. So in this case, non-initialized memory block will have the value 0, and dynamic initialization we have just did it with the scanf. Okay, so in scanf, most important part, we need to pass the address of each and every memory block, right? Now last part in this basic introduction of 2D array, just two more things remain. Now see, relation to the declaration initialization. So let's see what I have written. While declaring a 2D array, number of rows can be omitted. Okay, it is not only declaring, when you do declaration and initialization together. Okay, so better to write this: declaration and initialization together. Okay, so when you do this, declaration and initialization, what we can do, rows can be omitted. We can omit the rows, but number of columns cannot omit. Okay, we cannot omit number of columns. Why? Because number of column determines the number of elements in each row. Okay, so it is become compulsory to specify the size of the columns, because column size will be fixed. We cannot have variable size column in C programming 2D array. Okay, so let us just see another example here. Okay, we have done the initialization, right? So let me just put this input stuff in a comment, else it will ask the input again. Okay, so now I am taking this another matrix here. Yeah, so now mat5, I do not want to mention the number of rows, but I want to mention number of columns. Okay, so this will be the syntax. So now if you want one line initialization, so based on the number of column, it will identify the number of rows. So suppose I want 2 into 3, 6 item. Okay, 1 2 3 4 5 6. Okay, 6 item. So now each row will have how many columns? 3 columns. So how many rows? 2 rows. So you can also calculate here number of rows. So integer row size equal to, same approach, we'll use the sizeof operator. We'll pass the complete matrix and we'll divide it by the size of each row. So how to get the size of each row? So we'll have now mat5 first row, just we are taking. So it will give me the number of rows. So you can print and check. Printf %d is the number of rows. Okay, so let us print here row size. Fine. And now let me just print here. So rows will be replaced by, let me just shift it here, it will be belong to this code. Now let me just copy the for loop and print it here. Okay, so we'll have here size row size, and columns are 3, and we are using mat5. So let's run it. Okay, now you can see number of rows print 2. Just a minute. Now run it. Okay, number of rows are 2, and the item I have passed 1 2 3 4 5 6. So I can omit here line number 47. You can see I have omitted the row, but I cannot omit the column. So let me just write it so that you can see. Now see, I get the error. I have given the row, but I omitted the column size in line number 47, so it raised an error. So we cannot omit the row. We can omit the row, but we cannot omit the column, because column number determines what? Here column number determines the number of elements in each row. By that your compiler will allocate memory for it. Okay, last part for this lecture, we're going to see addressing, how addresses are allocated. We have also seen for the 1D array. Okay, so here you also going to see now addressing. So let me just use the same concept. Suppose I want to print the address of this. Okay, so we have here 2 rows 3 columns, right? So now instead of the item, suppose, okay, let me just print the item as well as print the address. So now here address of each index. Okay, how we can get this? So we'll use the loop. Always we need to loop to work with the matrix or 2D array. So we'll take 2 loop, for outer loop row and inner loop represents the column, right? So now for the address we need to use %lu, and if you need to print the address, so how to get the address here? Yeah, we have mat5. Okay, so mat5 of I, and I am just using here plus j. Okay, so what is j? Represents column. So if I use the index directly, if I just write, okay, you can do this one also, no need. Yes, address of this. Okay, so now let me just print so that you can see the address. Okay, some warning. So let me just typecast it into unsigned long. Okay, now run this. Okay, again run it. No need. So now here you can see the values here. This particular value, okay, this particular value, just a minute. Yes, this particular value 1. Okay, 1. What is the memory? You can see 24. We have taken integer matrix, right? Integer matrix. So what is the size of integer? 4 bytes, right? So now next, continuous memory block. So if I take continuous memory block, 24 plus 4, it will be 28. So you can see 28. Then plus 4, 32. So you can see 32. Then 32 plus 4, 36. So 36 will go to the next row, where you can see, and plus 4, 40, and plus 4, 44. Okay, so here this one is important, how we fetch the address. So again, it is I hope you understood, continuous memory block. Okay, so that's why we can initialize in a single line way. Line number 47 it did the single initialization, and line number 17 also it did the single line initialization. That is the reason it is possible. Okay, because address are allocated in continuous manner. Okay, so I hope you understand how to declare and initialize 2D array in C programming. Okay, I'll provide the link of this particular program in the description of the video. Okay, please do like and subscribe the channel if you like the content. Thank you.